Okay, so in this video, I'm going to look at the inverse normal distribution. So basically, we're going to be doing what we've done previously, where we're finding out the probability that something is in a certain bound, except we're going to flip it. We're going to say we know it's inside of this bound. We know the probability of it being in this bound. So what is the bound? If that doesn't make sense, it will in a minute. So here's our first question. It's a bit tough to read. The mean is equal to 12. The standard deviation is equal to 3. Okay, so we know what our normal distribution looks like. Now we're saying that if the probability of the thing greater than C, some value, is equal to 0.4. What we want to find is find C. Okay. Bit of a weird question, so let me walk you through it. First of all, draw yourself a picture. Here's our normal distribution. The mean is equal to 12. The standard deviation is equal to 3. Okay. Now, we want to know if the probability of x being greater than some weird number is equal to 0.4, find out the weird number. X greater than something. So we're saying the probability that x is in here, the probability of this shaded area happening is equal to 0.4. So if the probability of that happening is 0.4, we need to find out what this C number is here. That's the setup, that's the graph. Okay, so let's get our calculator out. Menu, stat mode, distribution, normal distribution, and then we're using the third button here, inverse normal distribution. Okay, so looking at it, variable, data, variable, tail. Now you've got to decide, is the tail left or right? Just look where you've shaded. I've shaded the right tail, so I need to make my tail right-tailed. Okay, the area. The area is the shaded bit. It's also the probability. So the area in this case is 0.4. Okay, and then we put in our last two bits here. The standard deviation is 3. The mean is 12. Now, unfortunately, this won't draw it. On some of the newer calculators, it will, but on mine, it's not going to. Okay, and the answer is 12.76. That means that this number here is 12.76. So, rewriting this, we can say that the probability that x is greater than 12.76 is equal to 0.4. That's all we've found. The number that it should be greater than for it to be equal to that. There's some weird algebra that goes along with it, some numbers and stuff, and some symbols, but that's what we're trying to find. I'm going to do a left-tailed one. Okay, this one looks slightly different. Second example. Now I've got a mean of 0 and a standard deviation of 1. Now that's called the standard normal distribution. Now, when we're using standard normal distributions, it's a special kind. But when we're using it, we don't use the letter X, we use the letter Z. So if you ever see the letter Z, just know that that means you've got a mean of 0 and a standard deviation of 1. So if we don't tell you that, but you see the letter Z, that's what it means. Okay, the big difference here, though, beside that little bit, is that we're not doing greater than C, we're doing less than C. All right, so first of all, draw up your normal distribution. There it is there. Mean. Now the mean is equal to 0 and the standard deviation is equal to 1. Now we need to know the letter C so that the area is 0.7 or the probability is 0.7 and it's less than. Okay, so small issue here. You might be tempted to put it on this side and colour it in like that. But because the probability is 0.7, it's more than half of the normal distribution. So it's actually going to be a line here somewhere, and all of this shaded in. 70%. And we need to know what the value of C is here. That's going to make it less than that. Okay, let's get our calculator out. Stat mode. We're in the inverse section still. Might just brighten this up a little bit. Okay. Now, it's a left tail this time because the shading is on the left-hand side of the line. The area is 0.7. Standard deviation is 1. The mean is 0. Calculate it. And we get 0.52. So we can rewrite it. The probability that Z is less than 0.52 is equal to 0.7. That means that C value is 0.52. That's what we've just found there with our inverse normal. Alright, there's two basic inverse normal distribution questions. There are more and more difficult ones. I'll let you discover them when you do your exercises. If you do one and you're like, man, I don't know how this one works, you need to come and talk to me because they do get more complicated than just these two. Alright.